a not-for-profit organization called CREST, has been at the forefront of industry-driven collaborative R&D activities in Malaysia since 2012. It leverages on the strengths and resources of 102 companies and 25 universities. CREST is also backed by the Malaysian federal government through EPU, MITI, MOSTI, MIDA, and NCIA. In the past 10 years, CREST has facilitated government grants amounting to 58.7 million ringgit for 132 R&D projects. Industry and university contributions amounting to 109.7 million ringgit for 132 projects. Completion of 85 R&D projects. Filing of 52 intellectual property or IP applications, and generation of estimated R&D value amounting to 266.3 million ringgit. 2022 marks the 10th anniversary of CREST. In this fifth and final session of the CREST 2022 video sessions, we talk about the trends, prospects, and opportunities in high-tech industries for the future from the global and Malaysian standpoints. Our video sessionists today are leaders in the leading MNCs that are operating in Malaysia. Their companies are among the 111 members of CREST.
Welcome to the fifth session in the CREST 2022 video sessions series. 2022 marks the 10th anniversary of CREST in facilitating collaborative R&D initiatives in Malaysia with the full backing of 102 companies, 25 universities, and the Malaysian government. In this session, we will explore the prospects and opportunities in 5 generic technology clusters that is of interest to Malaysia, Malaysians, and Malaysian manufacturing sector. So these sectors are LED and Optoelectronics, the Internet of Things and Embedded Systems, Integrated Circuit Design, Industry 4.0, drones and autonomous vehicles. For this session, I would like to welcome Mr. T.K. Tan, the Managing Director of Clarion Malaysia, Dr. David Lacey, the R&D Director for AMS Osram, Mr. Eric Chan, VP and GM of IOTG, Customer Engineering for Intel, and Mr. Chia Hoon Wah, the Founder and Chief Technology Officer of Opstar. So let's start with Dr. David Lacey. Can you please help us explain what gallium nitride? I think you spoke a little bit about what we've done with gallium nitride from a research standpoint, but can you give us a few simple examples of what is gallium nitride to the everyday person?
Gallium nitride is an example of a compound semiconductor. That's a new class of semiconductor materials which is finding applications in a variety of areas such as power devices and radio frequency devices. The reason it's doing that, it started off with optoelectronics, LEDs, where gallium nitride will emit light across a broad range of frequencies. So that's one specific value of compound semiconductors, which they can efficiently emit light. But the other advantages of the class of materials, compound semiconductors, is high reliability and high efficiency. So with those attributes, you can make power transistors and power devices which are fundamentally more efficient. And that means the power supply for your laptop or your phone is smaller. It means the total efficiency of an electric car in future is higher because the power conversion losses are reduced. So that's enabled by compound semiconductors. Same with radio frequency. Radio frequency devices become more reliable, more efficient. That's the transmitter in your cell phone and the like. So compound semiconductors enable a next generation of high efficient, high reliable electronics, and that's something which silicon can't do. Only compound semiconductors can do that.
Thank you. Now we move on to integrated circuit design. Mr. Chia Hoon Wah, can you please provide us with some insights in regard to the state of the art for IC design and the prospects for the future and how it can impact us in Malaysia.
Now, IC design is an art, I will say from a layman perspective, right? Integrated circuitry, if you ask me, is actually a miniature of circuitries, right? The key components actually encompass two key elements, right? It can be a discrete component, whereby a lot of analog circuitries incorporate into it, and the other element is actually digitized, right? So analog and digitals actually is actually to come together into it. And with today's semiconductors era, right? And if you ask me from a digital IC design perspective, it's actually made up of all the standard switches, whereby from a technical perspective, we call it transistor, right? The number of transistors actually, if I take a smartphone, right? Today, the top 5 world smartphone maker, right? The total transistor actually is more than the world populations. I will throw out the challenge. If today, let's say, if I take the world top 5 smartphone maker, right? It's actually tens of billions transistor count. If you take this out, actually it's double of today's world population, right? This actually itself surpassed the Moore's law as we are well aware of, right? If you ask me, from let's say electrical vehicle perspective, automotive per se, right? All day a truck consists of perhaps hundreds of chips in a vehicle. Today with EV per se, right? It's actually surpassed, I would say easily about 2,000 and more, right? Now this itself, it encompasses whole lot more, right? Now set aside that, let's say artificial intelligence is actually going to transform the world, right? A lot more connected devices are actually coming in, right? Smartphone itself is actually tens of IC chips, and with a lot more coming in, I see this opportunity actually coming ahead, and I actually with a very open mind, this itself for the next decades, a lot more focus is actually coming into this area.
Why are we in Malaysia uniquely in good position to pursue some of these opportunities, Mr. Chia?
So today, actually, if I see Malaysia is such a beautiful country, especially in this Penang Island, right? I always say that we have the geography advantage, right? Where it's east meets west kind of things, right? Today, the design itself, if you ask me, actually, this country, we have a lot of actually multinationals, and with the past decades, multi-decades of the involvement into the top-notch design, and also the downstream of the technologies, right? Both the front end as well as the supply chain towards the back end. I see today we are able to transform, whereby to capitalize into some of the segments that I mentioned earlier, right? This is one. Now, secondly, right? Today in the nations also, we want to create a few more technologies. As I mentioned earlier, IC design is an art, right? To architecting it, actually, we need to start up from the ground up, right? In the past, if some countries may not be able to do it today, if we are not taking these steps, right, for the next 10 years, perhaps next 20 years and 30 years, we can churn out some fantastic toys to be in the world. That's where I view it this way. Yeah.
Thank you. Thank you so much. Dr. David Lacey, would you be kind enough to give us a quick overview of the prospects and opportunities in the world of LEDs and optoelectronics? Dr. Lacey?
Thank you. Optoelectronics, we are in a phase of miniaturization now. So we have demonstrated over the last 10 years efficiency and low cost. So now LEDs are close to the theoretical efficiencies, and certainly will get there in the next few years. The low cost enables shrunken LEDs, much smaller physical size, to enable displays. So one of the big future areas for optoelectronics is displays. I think you know those large outdoor video walls or advertising displays that you see from the cities. But can you imagine shrinking that so that it becomes the TV in your home, or the display on your phone, or the display on your watch, or the display in your vision? So all of those technologies will use optoelectronics in future. So one of the hot areas at the moment is augmented reality, virtual reality, the idea of projecting images into your vision using very small displays. And only optoelectronics enables you to make a display which is physically small enough and has the performance that you need to make a light pair of glasses with high performance. The other thing which will happen is the topic of what's called sparse arrays. So in other words, instead of packing the LEDs together, you can spread them out. And the human eye enables you to still see it as a continuous display, but in fact there's a lot of space between the pixels, and you can put other things in that space, and that's a potentially very interesting area for making combined devices. For instance, combining cameras with displays, or combining other sensors with displays. So that's one huge area of future development of optoelectronics. Another is in the autonomous vehicle, this topic of LiDAR, light detection and ranging. So using infrared lasers, optoelectronic lasers, to enable a car to see where it's going. Sure, you can do that with cameras, but cameras, you know, as a human being, you rely on your stereo vision, and your brain is good at computing that vision and constructing a 3D picture. LiDAR is the easiest way to construct that 3D picture for a computer system. So the idea of high power infrared lasers for autonomous vehicles is another opportunity. And then many optosensors. So if you think about drones and things like that, the reliance on sensors to know where the drone is and ensure its stability, those are opto devices as well. So opto devices are embedded in many things. And will continue to develop there.
And are these opportunities that's within reach for Malaysia and Malaysians?
Yes, I think certainly yes, because they all require to be translated from concept into manufactured product. So the situation with many of those things I talked about is that the concept has been shown. If you read the literature, you'll find examples of proof of principle here. Mm-hmm. And the work, we always say innovation is actually getting something into the market where it has an impact. So the inventions are done. People have invented small displays and like. Now we need to make it a proper innovation. We need to translate it into product. And Malaysia is in a great place to do that. The manufacturing infrastructure is here, and together with CREST, we've made sure that we've got the scientific knowledge to support it, so we can develop those technologies into products and really innovate.
Okay, thank you. Next up, we look at the Internet of Things and embedded systems. I would like to invite Mr. Eric Chan to talk about the status and future of this technology cluster. Mr. Eric Chan?
I think most of us are familiar with the evolution of the PC, the personal computer that we use every day at work and at home. The embedded systems are very similar to the PC. They share the same hardware and software architecture, but with one big difference. They are designed for dedicated purpose and being deployed in retail or industrial environment like self-order kiosks in fast food restaurant, ATMs in the bank, or robots in the factories. The Internet of Things, or IoT, is the evolutions of the embedded system where we, by connecting these embedded systems to the Internet, we can remotely update and manage these systems in the malls or factory. Now that we have real-time access to the Internet of Things, we can then extract the data that are being generated and apply artificial intelligence, AI, to turn this data into insights to improve the business goals. For example, through the self-checkout system that I just mentioned earlier, the fast food restaurant know exactly what the customers are ordering in real time, and they can better plan on the supply management or do more promotions on those items that may not be selling well. In the case of the robots in the factory, they get better through the training using AI algorithm, and over time improve on the quality and accuracy. Manufacturing as a whole, whether in the E&E sector or other industry, is a huge economic engine for Malaysia. And that's, I think, it's important that we invest in IoT to stay ahead of the Industry 4.0 requirements and transition to smart manufacturing for us to stay competitive. This is where CREST can play a pivotal role in leading the initiative to do more collaborative research with the industry and university on Industry 4.0 and AI applications, and share those learning with the local industry partners.
Excellent. Yeah, I mean, that's a very good way of explaining it. It used to be the mainframe where everything is done in one central location, and then it moved to the mini, and then it moved to the personal computer. Now it moved into devices. The computing is done, and you use software like AI to drive and to extract information and so on. What would you say would be the opportunities for us Malaysians in that space as in terms of research and building our own devices? Do you have any views?
Oh, yes. So we have the benefit of having a large manufacturing base in Malaysia. All right, as you can see, a lot of MNCs and local SMEs as well already invested in Malaysia. And we have built up a strong talent pool. And therefore, I would say we are a little bit ahead than maybe even other countries on having the right talent, the right setup, and of course, the connection to some of this high-tech global supply chain. So I do see opportunity for Malaysia through the investment, through the MNCs, SME, and the government to take full opportunity of what we have, and then continue to stay ahead on the Industry 4.0 to make sure that we are always progressive and able to compete at the global level. And therefore, I think it's important in few areas. One, the talent piece, to make sure that we always have good talent. Two, a bit of the push from the government, the universities and industry to make sure that the whole industry keep up with the requirements, especially on Industry 4.0. And then lastly, maybe in the case of CREST, do a bit more research to make sure that we are always having good research and collaborative partnership with the university to kind of keep us on the leading edge.
Thank you. One of the things that I've been hearing about of late with regards to IoT as well is the security aspect of it. Is Malaysia ready to be able to build solutions and protect ourselves from attacks?
Yeah, I think that's a really good question, Jeffrey. And you hear a lot of this cyber attack, ransomware, and one of the biggest, I would say, concerns, as well as maybe the so-called hindrance for more IoT deployment is because of security. So as we open up factories to be interconnected, you naturally open up for more some of the cyber attacks in a way. So, but this is where I feel if we continue to stay very close to the industry, whether it is from Intel at the chip level, software at the OS level, we are putting in a lot of new technologies to prevent some of this cyber attack. Some of it are down to the silicon level, some of it naturally at the software level. So I think, again, back to my point, that you do need talented people are very savvy in software, hardware, high tech to really understand. Because a lot of security is really it never ends, right? You patch one gap and they find another gap. So it's really a matter of just keep up leveling it so that it's so much tougher for them to come and attack the system, and that way, after a while, they some of these hackers give up because it's so much tougher and it's not worth their time to go attack some of this. So, but I do agree with you. Security is a concern, and we need more investment there to figure out how to continue to improve our security. And I think this is where again, CREST can do its part to really partner with the industry and the universities to do some further research on some maybe new breakthrough in security that will minimize a lot of this I would say maybe the low level
dangers,
attack.
yeah. Mm-hmm.
Yes.
The next technology cluster that I would like to maybe get some views on is Industry 4.0. So, Mr. TK Tan, I think we've had several conversations about how Industry 4.0 serves the world, and where does it play a role for us in Malaysia? And what do you think is opportunities for us in the near future?
Let me just quickly explain my perception of Industrial 4.0. Industrial 4.0 basically uses software to determine operation characteristics between supply chain, the manufacturer, and the consumer. Meaning, for example, my raw material coming into my factory, the raw material can be sub-assembly, and my customer being car makers. Yeah. So the Industrial 4.0 requirement is for optimum timing for when I receive what I need to assemble, and in minimum time deliver to my customer, who then has to put it together in a car. For us here, there are a few parts that we can play major, because the manufacturing facilities and the design facilities are already here. The supply chain is well known over the last 30 years, so it is in line, and a lot of components are made here and across Asia. The part that we have to focus on is the meshing of software. Meaning, if the whole plant is automated, it doesn't matter where it is. You can ship a fully automated plant anywhere in the world. It's running on electricity. It doesn't have much human inside, consumption. However, the system that can support it, from supply chain delivery and meshing of software and the operation of the highly automated plant, again, depending on the maintenance of the facility, majority in software meshing, to be able to get it to the port and the supply routing, to make sure that the customer knows when your parts or your modules is getting in your factory, when it's going to be ready to ship out, when it is on the ship or it is on whatever transport. That is something that will shorten a lot of problems. And we got to be good in this. You already have the factory, you already have the engineers, you got to get the software experts in, you got to be able to mesh and maintain the facilities. Otherwise, you don't have a role in this game. And to me, again, the advantage is long history manufacturing, engineering, R&D starting up with CREST supporting the ecosystem, to be able to tell the government Industrial 4.0 is not just a buzzword, but needs time and investment to work through to make sure Malaysia capture the advantage. Singapore is a hub, transshipping hub. Malaysia is manufacturing, sourcing, designing, and also a hub. So tell me, how are we not going to win if we stay focused? I mean, to me, it's brainless for not doing it. And to do it quick with CREST is easy. But to share the information, I think is our role right now in CREST. Yeah, David? to make sure we can show to our own group within the world, as well as what the government is going to come in, step up and do for the whole group of every multinational in Malaysia. No country has addressed this properly. And I think that is one big advantage. Actually, I've been thinking about to entice the board member who is going to be the flag carrier for this one.
Right. So last but not least, let's talk about a bit about the drones and autonomous vehicles technology cluster. I know all of you may have some contribution to this particular cluster, but let's start off with Mr. TK Tan. Can you give us, your views on what is the latest and what's the opportunities also in the world of drones and autonomous vehicle?
For us, we are a device maker.
Yep.
We make product. A common requirement for IoT, smart city, drones, and autonomous. One of the items is LiDAR that David has mentioned. You use it all across, yeah? Can we design LiDAR? The answer is, don't think it's difficult. It's just another product. Can we get component? David is sitting there. Is one of the major costs of every LiDAR is the laser. All right? And he's in Penang and he's sitting on your board.
Absolutely.
A car, an electric car, 50% is a battery. You don't have the lithium-ion battery, you don't have a car. For a LiDAR, you don't have laser, you don't have LiDAR. And he's sitting here with us talking about GaN-on-GaN, talking about LEDs, talking about laser. What else do you want me to tell the government? It's here. Are we going to do it or not? That's all. Sorry, David, please take it.
Okay. So, David, do you have some views on this?
Yeah, I think we have the building blocks. As TK just said, if you look at the components you need to build an autonomous vehicle, then many of those key components, there's a significant global contribution coming from Malaysia. And Malaysia itself has not really leveraged that, as TK said, to build its own autonomous technologies. So got to be careful now not to reinvent the wheel, but building on what Malaysia has to enable autonomous technologies is something which is entirely doable and is a bit of a blind spot right now. We don't have a great deal going on, but all of the building blocks are there.
So, gentlemen, I guess we've done, thank you so much for your contribution. We've covered some areas here, but maybe you can share with us some of your final thoughts about what you think we can do as a country and what CREST can do to bring the industry to the next level. So your final thoughts, maybe we can start with Dr. Lacey.
Malaysia's in an excellent position in the electronics industry, which is recognized from a revenue perspective, but less recognized from a technology perspective. And I think it's time for CREST to help Malaysia recognize the huge value of that electronics industry and apply it to tackle global problems and local problems and drive local innovation. So only CREST can do that, because only CREST has got in Malaysia that network of knowledge of the electronics companies and the supporting ecosystem of universities and SMEs and the like. So looking forward, we can build on this fantastic electronic space to enable all areas of technology in Malaysia to innovate and develop world-class products. We're in a special position. Doesn't matter whether it's a drone or an IoT device or whatever, the components are here, and we just need to build on the network which CREST has to enable innovation.
Thank you, Dr. Lisi. Mr. TK Tan, do you have any thoughts?
I think the awareness for the next generation of workforce, and I don't mean just university, tech college, high school, all the way,
Yes.
The requirement of software in every product, it's real. I can't see any product today that I carry or I use without software in it, even light bulbs, okay? R&D, the promotion of R&D activity from academic institution to SME, all the way to MNC enablement requirements, so that everyone can see the same picture for R&D requirement. And the last but not least, for any startups in Malaysia, which I'm sure there can be many more that I am working right now with CREST to try to enable the ecosystem or the incubator to do, cybersecurity, again, software. If you can't securely protect the product from being hacked, and when everything is connected, wireless, nothing's going to work. So the seriousness, again, to disseminate this kind of information to the government, to the industry, to the SME, to the startups, that culture is required. And I think there is no other institution right now that I can see that can bridge all the gaps to everyone right now. And it is going to impact whether the product is sellable in anywhere in the world. Doesn't matter whether you're doing IoT, smart city, nodes, automotive components. You can't secure it, you can't sell it. And I think CREST is the best entity right now to promote this, and we need to really address it for everyone in the community, in business right now.
Thank you, sir. So, Mr. Chia, do you have any final thoughts about how you think CREST can help us bring the industry forward to the next level? And what do you think is opportunities in the IC design space?
Thank you very much, Jeffrey. Now, as far as autonomous or automotive industries are concerned, I see from a drone and even autonomous vehicle per se, from an IC design perspective, I see two elements that actually as a key contributor and the focus that the team can put forward. One from the radio frequency, the RF perspective. Now, secondly, as far as this wireless protocol, right? So these two itself actually play a fundamental architecting from some of this automotive industry perspective, which actually I see the nations and from the leadership from through CREST, this actually enable the nation to march forwards, focusing from the architecting perspective as well as the whole downstream of the entire semiconductor.
Yeah, thank you. And finally, Eric, what would be your advice to CREST? What do you want us to do to up the game a little bit with regards to helping the industry prepare itself for the next stage?
Yeah, I think for that, Jeffrey and the team, I want to congratulate you for, everything that the team has done, CREST has done for the past 10 years almost, right? So I think this is where I feel we could take a lot of the learnings and understand the good work that we have done, the impact that we have done, the collaborative research between industry and the universities, and some of the talent development program, some of the really reaching out to the younger students to kind of excite them to go into STEM, right? So I think there's a lot of learnings there that I think CREST could take a look and see how can we apply some of this for the next 10 years and continue to stay very engaged with the industry, get the feedback, because it's very much industry and university-led. I do think CREST is a good a lever, right, to take the full strengths that you have in partnership with universities and industry and really drive a lot of impact, given a bit of the fulcrum effect that you have, being the pivotal role that you play in the industry.
Thank you so much. That was excellent. Well done. On behalf of CREST, I thank all our CREST 2022 video participants for joining us today to share their insights and viewpoints. Malaysia has the potential to achieve future successes in the exciting tech cluster which we have discussed today. However, in today's high-tech world, things move at light speed. In the race to engineer a brighter tech future for Malaysia, we cannot afford to be left behind. Moreover, we cannot succeed or excel if we are merely followers. To ensure success, we must seize the opportunity to emerge as a leader in certain fields or areas of expertise. To be a leader, we must develop, own, and hold more IPs and patents on new technologies. CREST's 10-year track record proves that we can come up with innovative solutions in gallium nitride research, noise reduction for two-way radios, and a machine vision inspection system to detect microcracks in solar panels. We have helped a Malaysian startup called Opstar to become a global player that is at the brink of a public listing. We have also helped bring the inventor of the AI-powered stethoscope to Malaysia. At CREST, we believe that Malaysia must continue to nurture and practice collaborative R&D to stay ahead in the global high-tech game. We are not alone. There are 111 CREST members, including leading MNCs, exciting new local startups, and universities that share our belief. I hope you have enjoyed watching our 5 CREST 2022 video sessions. Please let us know if there's anything we can work on together, or to make things happen, or to make things better. To find out more about CREST, please visit our website, crest.my.